Hi, and welcome to the curriculum preview for 5th grade science. We're going to be talking about what's coming up in the second 6 weeks for Unit 2, Energy, Force, and Motion. As always, we're going to be referring to a couple of key planning documents that are located in Forethought. So just a reminder, if you don't have these printed out, you might want to have them open in a view behind this particular presentation so you can pause the video and refer to those. We're going to be talking about the pacing guide, refer to some parts of the unit overview, and then look at some updates to the clarifiers today. So let's start with the pacing guide for the second 6 weeks. This is a one-pager that shows you the order of suggestion for teaching the standards, as well as the number of days for each one of the standards. So I want to talk just briefly about the why and how we came up with this order and the number of days for a particular standard. So if you'll take a look at the first row, you'll see listed for the leading standard 5.6a. And there's a partnering skill 5.2G, and we've got listed 4 days for that particular standard. So again, I'm taking a look at the top row right there, talking about 5.6A. So that might not seem like a lot of time to spend on a readiness standard. However, if we start to break down the standard, we will see that some of these forms of energy are review, such as thermal and sound energy. For instance, you just spent a lot of time on thermal energy when you were in Unit 1 in the first 6 weeks, and sound energy has been something that's represented many grade levels in the vertical alignment. And then if you look down at the pacing guide, for the last part of the 6 weeks, you'll notice we come back to electricity and then also light. So based on the vertical alignment as well as what's coming up later, that's how we've determined the days there. And we'll talk a little bit more about clarification about some of these forms of energy, but I just wanted to point out that we do look very carefully about performance on STAR, performance on CBA, as well as where we might need to linger longer or where we're really ready to move forward on that. The next thing I'd like to do is just take a look again at the rest of the 6 weeks. After 5.6a, we focus a little bit more in on mechanical energy, and we spend 8 days showing students how to design an experiment, specifically that tests the effective force on an object. And so we've got that partnered with a supporting standard 3.6b, so you can go back and review some of those concepts. And you'll see in the partnering process skills, there's a list of many process skills over there on the right. It's worth noting that the students have only done a formal experimental design in 4th grade in one of their content areas, and it was testing the effective force on an object as well. So you will probably want to spend some time doing some mini lessons about some of these process skills. After that, we have about 8 days to talk about the flow of electricity in different circuits, producing light, heat, and sound. And then we end up the 6 weeks with properties of light, and we've got the properties of light, how it travels, how it can be reflected, and how it can be refracted. So now that you have an overview of where we're going for the second 6 weeks, I just want to point out that it's extremely important to stay about in this same time frame. It's very easy to get behind, especially at the beginning of the year when we're trying to set up some of our procedures and our notebooks and so forth. So while these days are not prescriptive, if you're going well beyond or covering them a lot faster, you might want to take a look and see where you can really shore that up. Before we leave the pacing guide view, I do want to just briefly talk about our performance on STAR last year for these particular standards, which also influences and impacts our pacing guide. So next we're going to take a look, in the left-hand side is going to pop up our performance as the district results, and then also how many items were on this last STAR assessment 2016. So when we look at exploring the uses of energy, there were 3 questions last year on STAR for this particular standard, and when we averaged those out for the district, we got about a 74% students that answered those correctly. So it just kind of gives you an idea of where we are. As we move into designing an experiment that tests force on an object, We had one question and our students performed at 81%. And then we also had one question that was aligned to 3.6b, and we scored 68% on that one. For demonstrating the flow of electricity in circuits, we had 3 questions on that for STAR for 75. And then properties of light, there were 2 questions on that and score of 71. So I think this is a helpful view for you as a teacher to kind of see where we're going as a district. And of course, you'll want to kind of maybe focus in on the performance at your campus level in the same way. So you might find it to be useful to print out the pacing guide and actually write how your students did on these different standards, and that might kind of help you again either decide you need to add an extra day or if what you did last year seemed to be working for your students. Okay, so just a couple of key points that I want you to take away from the pacing guide. Please do note that the process skills are specifically listed with a leading content standards, and those are done by design to really support each other. Excuse me. So in 5.6a, I do want to talk a little bit about why we have the 4 days total for there. So we have the standard just summarized here, exploring 5 different forms of energy, and we do cover this in about 4 days. So let's just chunk this a little bit. With mechanical energy, that's the energy of motion and position. And last year we talked about really covering potential and kinetic energy pretty thoroughly, but I want to pull back away from that a little bit this year. And I think we can buy back some time because that is specifically covered in the 6th grade. Looking at the 6th grade performance on CBAs for this, I don't really think they need that much help from us in 5th grade to spend the extra time to preview that. I think they're doing great. So we're going to go ahead and pull back and maybe preview what potential and kinetic are. But if you really spend a lot of time with your kids looking at the difference between the two, feel free to make that a much more introductory concept than something that was more in depth. And we'll take a look at the vertical alignment on the updated clarifier in just a moment. Also for light and electrical energy, we need to introduce that here, but remember we're going to be covering it more in depth later on in the unit. They have their own specific standards that we can go more in depth. And then thermal and sound energy, just a reminder that vibration equals sound. Those we need review, but you just talked a lot about thermal energy. And sound energy is pretty well represented in the curriculum all the way up from about 2nd grade. So before we leave 5.6a, this is a screenshot from the updated clarifier. I did update all the clarifiers for 5th grade so far and made sure to include the 6th grade alignment. I feel strongly we need to really see where our kids are going so we know what we need to be covering. So that's something we'll be doing this year. And so if we look at the alignment for 5.6a, we can see that there is a lot of standards that are related to that, but I want you to focus right here. And this direct vertical alignment for 5.6a goes up to 6.8a, and you can see there that they're going to be specifically comparing and contrasting potential and kinetic energy. And then that is a supporting standard for STAR in the 8th grade. So just to give you a little bit of an idea of what that's going to look like next year and the years beyond. Okay. The other point I wanted to make about the pacing guide was that 5.6d, and that's designing an experiment that tests the effect of force. It is a supporting standard, but it's partnered with several really important process skills. And this is where we really hone in on experimental design. And that would be a formal creating a hypothesis, designing the investigation, choosing the variables and making sure that we're only using one variable that will be changed, and all those process skills that are listed that go with that. Please do make sure that you check with the unit overview for those resources, and as I've updated those in the unit overview. Also 5.6b, this is demonstrating the flow of electricity. Students, just as a reminder, have had experience building circuits in 4th grade, so they should come to you knowing how to build those simple circuits. And note the partner skills are both process skills of concern. So we've got 5.2b and 5.2d. And again, you can look back at the pacing guide to take a look at those. One thing I did want to point out and add this year is that students really should have opportunities to explore both series and parallel circuits. And so as we look at the released items, we can see that that standard is really represented with both. And so I've made some updates to the resources in the unit overview to help you clarify for yourself as well as your students what those look like. And then finally, the properties of light. We do introduce this concept and it's partnered with 5.2D, which is the inferencing process skill, and it does use several tools. So we spend about 8 days on that. And if you'll look at the unit overview, I've tried to really highlight how you can chunk that standard into 3 specific parts to kind of break that up a little bit. Okay, so moving away from the pacing guide, this is just an overview of the unit overview. We're not going to go specifically into it, but I have made a few updates based on some clarification I think we need from last year. So the first page includes an overall view of the scope and sequence, as well as guiding questions. The next 2 pages are hints and tips, so this will be background information that I feel like our teachers really might need to focus in on. And then the last pages are the resources by standard, and that's where you're going to find some of the parts that I feel like are particularly strong for that standard in STEM scopes, AIMS lessons that go well with that. I've looked in EduSmart to see if there's some pieces in there, as well as maybe some videos that can help you clarify some of those things. So this has been updated with a couple of new resources or clarifications, so you might want to check that out. Okay, this is just a view of some of the listed tools that we have for this particular 6 weeks. You'll be using a lot more as you do your investigation for the forces, but the spring scale is listed, so your students definitely should use that. They should be using a prism and a mirror for properties of light, and then with your investigation for your experimental design, you'll probably be using meter sticks as well. So again, with the overview, just want to make sure that you know what the function of those parts are. The guiding questions really should be used as discussion points for your kids, or you can even use those as little formative assessments. So if they can answer those questions well using the unit vocabulary, they're doing great. The approaches to classroom use, those were those hints and tips that I talked about. And then the resources are a list of our district resources that we have for each standard. I did want to talk for just a moment about vocabulary and remind you that the teacher toolbox has the tool cards with images. The ones that you see on the screen right now came from there. But I want to talk a little bit about vocabulary because in the teacher toolbox, or sorry, in STEM scopes, you can find picture vocabulary with a lot of teachers use. So I want to talk about some clarification on that for just a moment. STEM Scopes does have a section called Picture Vocabulary, and it has some, but really not all the vocabulary for the standard. So I just wanted to remind everyone to make sure to use the list that's on the clarifier. So let's look as an example here for 5.6C. When you look at the clarifier, you'll see a list of academic vocabulary, and the first words on the list come directly from the standard. So you can see the verb for this is demonstrate, and then I've listed some of the key academic vocabulary. Looking back into the released test, as well as maybe areas in the curriculum where we need some clarification, I will also have some related terms on there as well. So this would really be the starting point, and the words on this list should be the ones that you really focus on as your primary words of instruction. So let me just pull over STEM scopes for a second, and if you're relying on picture vocabulary and STEM scopes, let's take a look and see what they have in there for this same standard. So I'm in STEM scopes and I'm in 5.6C light, and I've pulled up the picture vocabulary piece. Okay, so this is in explain. So if we take a look and see what words they have reflection in a gray image here, and they have a definition. They have refraction, and they have lens. Those are the only three words that are listed on the picture vocabulary. As I go back through, we'll see reflection back again. So that has some of the keywords, but you can see it's not a comprehensive list. The other thing I want to point out too is to be very careful about these words listed underneath. STEMscopes has these listed as the challenge yourself words, and while some of these words might be words that are directly related to our particular standard, some of them are way, way out there. Like photon is not a term I would necessarily use with fifth graders when we're talking about properties of light. There are some others in here that do relate, and when you click on these, you will see it opens up a little twig video that has some nice illustrations, and usually about 1 minute. And again, sometimes these are related directly to the standard and sometimes they're not. So this video, as we continue to watch it, talks about the change of direction of a wave. So it does mention light because light travels as a wave, but it also mentions sound waves in water as well. So just be careful using those and make sure that they are tight fits for our particular standard. So I'm going to pull this back away and continue on here. Okay, so that wraps it up for the second 6 weeks. I wanted to end just by reminding you that if you're watching this, you've found the curriculum preview in Canvas, so congratulations. And something else that we're trying to do to meet the needs of our teachers from some of your feedback is, in addition to this digital curriculum preview, we're also offering what we're calling the C3. So this is a face-to-face time with coordinators and your colleagues. It's a come and go time. It's really driven by what you need. So you come bringing your questions or your ideas. If you need to see some equipment set up, we can show you that. It's really whatever you need. It's informal and it's optional. And this is an extension of the curriculum previews that we have this year. So if you're interested in coming to that, you will find back on Canvas, underneath where you found this curriculum preview, you'll find a s'more that gives you a little bit more detail about it, as well as the link to register in Eduphoria, and includes the date. So thank you for joining me. Y'all have a great 6 weeks, and please let me know how I can help support your instruction.